Hello everyone, myself Karan Das. I am a student of Kuchbihar Government Engineering College from Electronics and Communication Engineering Department. Today, we are diving into something every electronics and communication engineering student should know: classification of signals. First thing first, what is a signal? A signal is a time varying quantity that carries information about a physical phenomenon. Simply put, a signal is any function that carries information. It could be an audio form, a digital code, or even your heart rate over time. If it varies and conveys some kind of data, it's a signal. So, classification of signals has five types. First one is deterministic signal and non-deterministic signal. Second one is periodic and non-periodic signal. And third one is symmetric and antisymmetric. Fourth one, energy and power signal. And the last one, not the least, casual and non-casual signal. Okay, now what is deterministic signal? A signal is deterministic if it can be described mathematically and predicted exactly at any time. That means the deterministic signal can be predicted. A non-deterministic signal, a signal is non-deterministic or random if it cannot be predicted exactly. It may still follow statistical properties, mean like just like mean variance, but its exact value at a given instant is uncertain. That we can difference between deterministic signal and non-deterministic signal is that deterministic signal is predictable, non-deterministic signal is not predictable. So now we are differentiating with these two signal by continuous time signal and discrete time signal. So, in continuous time signal, deterministic signal defined for all real-time values predictable. Example, xt equal to 5 sine 2 pi t. And continuous time signal for non-deterministic signal defined for all real-time values but unpredictable. Example, thermal noise in an analog circuit. Discrete time signal for deterministic signal defined only at discrete sample points still predictable. Example, xn equal to 3 cos pi n pi by 4n. Non-deterministic signal for discrete time signal defined at discrete points still unpredictable. Example, random sequence generated by noise in a digital system. Now, periodic and non-periodic signal. Periodic signal. A signal is periodic if it repeats itself exactly after a fixed interval of time or samples. Mathematical for continuous time xt equal to xt plus t. Xt plus capital T, where capital T greater than 0, capital T is time period. And for discrete time signal, xn equal to x small n plus capital N, where capital N is positive is integer. We should know that capital N always be an integer. Non-periodic signal. A signal is periodic if it does not repeat after any finite time or number of samples. Continuous time signal, we know continuous time signal equation for periodic signal is x small t equal to x small t plus capital T greater than 0, capital T is time period. Now example, x small t equal to sine 2 pi 5 small t. Now from the equation we get uh, x small t plus capital T equal to sine 2 pi 5 small t plus 2 pi 5 capital T. 2 pi 5 capital T equal to 2 pi k t equal to 1 by 5k, it's a time period. Fundamental time period is when k equal to 1. So here the fundamental time period is 1 by 5. Non-periodic signal does not repeat after any finite time period. Discrete time signal for discrete time equation, domestic time equation is xn equal to x small n plus capital N equal to integer. Example, x small n equal to cos pi by 2 small n, x small n plus capital N equal to cos pi by 2 small n plus pi by 2 capital N. Therefore, pi by 2 capital N equal to 2 by k. Therefore, capital N equal to 2k. It's a time period. Fundamental time period is also k equal to 1. So here the fundamental time period is 2. Non-periodic signal does not repeat after any time number of samples like capital N. Now, symmetric and antisymmetric signal. Symmetric signal. A signal is symmetric even if it is a mirror image of itself about the vertical axis. Antisymmetric signal. A signal is antisymmetric or odd if it is the negative of its mirror image about the vertical axis. Continuous of signal symmetric even x minus t equal to xt. Antisymmetric odd x minus t equal to minus xt. Now assume it's the B side, it's the A side. Okay. Then if you assume the y axis as a mirror, then you will get that the A side is exactly opposite mirror image of B side. So it's a odd meaning antisymmetry because it will be the negative mirror image of that self. Okay. And now also assume that it's a B side and is A side. So here we can see if y-axis is a mirror, assume is a mirror, then we see A side is exactly mirror image of B side. So it's a even symmetric signal. Here the difference. Okay. Now for the discrete time signal, it is a discrete graph because it has sharp edges like you see here, and so we can derive that. If you see it's a side and B side, let's assume, and it's a mirror, y-axis is a mirror, then you will see that it's the same exactly image of the B side. A is the same exactly, so it's a event for symmetric signal, and it's the opposite. A side, let's assume again A and B side. Y is the mirror image, so you can see the A is the opposite negative mirror image of the B side. So it's the odd meaning antisymmetric signal. Now, energy and power signal. Energy signal. A signal is called an energy signal if it has finite total energy and zero average power. Power signal. A signal is called a power signal if it has finite non-zero average power and infinite total energy. So continuous time signal and discrete time signal, the energy for this energy signal, the energy will be integration minus infinity to plus infinity modulus xt the whole square dt. It is the condition of energy signal. Okay. The E will be 0 to infinity, between the 0 to infinity. Here the power will be 0. Now, for continuous time signal, for power signal, P equal to limit t tends to infinity 1 by 2t integration minus 2 to capital T modulus xt whole square dt. Here the condition of that power signal P between 0 to infinity. Here E should be infinity. Discrete time, here also the formula is E equal to summation n minus infinity to plus infinity modulus xn to the whole square. 0 to E should be between 0 to infinity. Here power is also equal to 0. For the power energy, the discrete time signal equation is P equal to limit n tends to infinity 1 by 2 n plus 1 summation n equal to minus n plus capital N plus n. Modulus x n whole square. 0 power should be between 0 to infinity. Here e equal to infinity. Casual and non-casual signals. Continuous time signal. Casual continuous time signal is xt equal to 0 for all t greater than equal to 0. Non-casual continuous signal is exists for all t less than 0. Discrete time signal. Casual discrete time signal is xn equal to 0 for all n greater than equal to 0. Non-casual discrete time signal exists for all n less than 0. Alright everyone, that's it for today's session on classification of signals. From deterministic and non-deterministic to casual and non-casual and everything in between. Thank you. I hope you will like it.